Assalamualaikum and hi everyone. My name is Fazhilah Binti Zainol, final year student Bachelor of Science Honours Biology at UiTM Arau Perlis. In this video, I will present my final year project entitled Utilization of Eggshells as a Fertilizer in Houseplant Syngonium Phodophyllum, supervised by Sir Muhammad Lias bin Kamal. In this presentation, I will cover the introduction first, second literature review, third methodology, fourth result and discussion, fifth conclusion and recommendation, and lastly the references. There are 5 subtopics under introduction, which are research background, problem statement, significance of study, objective of study, and research questions. First thing first, let's have a look at the research background. Every type of plants, including houseplants, requires fertilizer for development and growth. So, what is houseplant? Houseplants such as snake plants, aloe vera, peace lily, and spider plants are indoor plants that are widely planted to decorate and enhance a house environment. In general, there are 2 types of fertilizer, which are organic and inorganic fertilizer, which provide the essential chemical ingredients to grow the plant. Organic fertilizer can be made from agricultural waste, livestock manure, industrial waste, and municipal sewage sludge. Meanwhile, inorganic fertilizer are chemical fertilizers supplying nutrients made from chemical resources for the growth of plants. Therefore, eggshell is primarily characterized as useless agricultural waste, which it is mainly disposed as waste, which it can cause environmental pollution. This research will discuss the utilization of chicken and duck eggshells to produce organic fertilizer. The problem statement of this study is the usage of nitrogenous fertilizer, where it is a significant contributor to soil acidity. On acid soil, the primary cause of lower plant production results from an imbalance in macro and micro components in the ground, which include toxicity due to the accumulation of hydrogen or aluminum. As a result of soil acidity, houseplants typically suffer from calcium deficiencies when they exhibit signs such as stunted plant development, the eventual death of terminal buds and root tips, as well as necrotic leaf margin on young leaf or curving of the leaf. This research is important because eggshells are the most widely recognized natural source of calcium, which it is approximately 90% more effectively absorbed from eggshell than limestone, coral, or oyster shell. Calcium helps to lower soil acidity, which helps to enhance the plant's growth. Besides, eggshell contains a trace amount of nitrogen and phosphorus, which it is an essential nutrient that accumulates naturally in the environment and is one of the major components required for plant development. There are 2 objectives of this study, which the first one is to produce fertilizer from chicken, duck, and the mixture of both eggshell powder, and analyze the micronutrient availability in each eggshell fertilizer using the ICP-OES instrument. The second objective is to compare the growth and development of houseplant Syngonium Phodophyllum fertilized with each eggshell fertilizer and eggs fertilizer, which is inorganic fertilizer, by measuring the morphological traits. There are 5 research questions of this study. First, what type of agricultural waste contributes to greenhouse gas emissions? Second, what is the effect of organic fertilizer on the soil? Third, how many micronutrients are found in the eggshell? Fourth, what is the impact of calcium deficiency on Syngonium Phodophyllum? Lastly, what is the benefit of calcium in plants? Now, let's move to the literature review. Every year, around 998 million tons of agricultural waste, includes animal waste, food processing waste, crude waste, and toxic agricultural waste, are generated, resulting risk to humans' health and ecological degradation. Adijumo and ADB 2020 reported that farm sectors contributes around 21% of global greenhouse gas emissions. Thus, recycling agricultural waste will reduce greenhouse gas emissions, and fossil fuel utilization can create new clean market, jobs, bioenergy, and bioconversion of farming waste to animal feed. Next, organic fertilizer produced from natural sources such as organic compost, animal manure, poultry waste, and domestic sewage. Compared to synthetic chemical fertilizer, organic fertilizer that are made from plant and animal waste contains lower quantities of nitrogen, phosphorus, and potassium. Therefore, it can enhance the soil structure and growth by slowly releasing the nutrients into the soil, which also provides energy for microorganisms. Malahayati et al. 2021 stated that chicken eggshells had a higher calcium content, which is 96.48% than duck eggshells, 90.9%. Meanwhile, Zhang et al. 2022 showed significant differences between chicken and duck eggshell in the amounts of phosphorus, which is 0.19% versus 0.29%, and magnesium 0.29% versus 0.09%. These macroelements and microelements are required in plant growth. Besides, calcium carbonate is an essential component in the bones of animal and the exterior shells, including eggshells and the skeletons of the marine habitats. so it will help balance the pH of the soil, resulting in an ideal environment for plant growth. Lastly, Syngonium phytophilum can be placed in the bedrooms without any issues because it amazingly effectively purifies the environmental air. Calcium deficiency and bacterial leaf blight usually occur in the Syngonium phytophilum, resulting in yellow and brown patches on the leaf that inhibit plant development. Thus, calcium in eggshell fertilizer helps stabilize various processes and control plant disease by aiding in mineral preservation and transportation in the soil. There are 5 main methodologies that I had used in this research. The first method is preparation of eggshells powder into liquid fertilizer. For this method, eggshells were collected from household wastage, restaurants, and fast food sectors. They was washed first with distilled water and lukewarm water to eliminate bacterial and virus contamination. Then it was heated with distilled water for 5 minutes until boiling. They was dried for approximately 10 minutes at 200 degrees in the oven. Eggshell was crushed by ground into small pieces for fine powder production. Lastly, 1 spoon of each eggshell powder was mixed with 1 liter of warm water for the preparation of liquid fertilizer. The second method is hot plate digestion of fertilizer sample for ICP-OES analysis. First, 2 ml of concentrated nitric acid and 3 ml of concentrated hydrochloric acid were added to each beaker. Then each beaker was heated on a hot plate in the foam extraction hood until the sample was just below boiling. Each sample was cooled to room temperature and transferred into 3 of 50 ml volumetric flasks. Next, the sample was topped up to volume with deionized water. Lastly, each sample was analyzed with the ICP-OES instrument. The third method is growing of Syngonium phytophilum. Syngonium phytophilum were planted in 4 different pots and each houseplant was fertilized about once every 2 weeks. The fourth method is measurements of morphological traits. After 30 days, the stalk length, leaf length, and height of each Syngonium phytophilum were measured. Then the measurements of each plant were recorded. The last method is descriptive analysis for morphological traits. The means of the morphological traits was analyzed using each plant's data. A graph of the mean morphological traits of each houseplant against each eggshell fertilizer was plotted using Microsoft Excel. Next, I will explain the result and discussion of this project. In this project, the micronutrient availability in chicken, ducks, and mixture fertilizer were analyzed using the ICP-OES instrument. Figure 1 indicates that the highest concentration of phosphorus is duck fertilizer with value 0.432 mg per liter, followed by chicken which is 0.370 and mixture fertilizer with value 0.313 mg per liter. There are small amount of phosphorus since it is distributed unevenly between the inner and outer layers of the eggshell. The phosphorus level in the eggshell is lower compared to the egg contents. So, the presence of phytate supplementation in poultry feed helps increase phosphorus availability while lowering feed expenses and feed production to the environment. According to Figure 2, chicken fertilizer had the highest concentration of potassium, which is 1.161 mg per liter. The concentration of potassium for duck fertilizer is 0.841 mg per liter. Meanwhile, for mixture fertilizer is 0.891 mg per liter. Tombarkiewicz et al. 2022 proved that chicken eggshells had a higher potassium content than duck eggshells. Therefore, the potassium of eggshell is influenced by chicken and duck species, feeding, genetic characteristics, and different evolutionary mechanisms. Figure 3 displays duck fertilizer shows the highest concentration of calcium, which is 69.48 mg per liter, followed by mixture and chicken fertilizer with value of 43.36 and 35.38 mg per liter. Dietary zinc methionine enhances calcium deposition in laying chickens, primarily due to increased expression of Ca and carbidin-1, a calcium-binding protein in the eggshell gland. Zinc is a necessary cofactor for carbonic anhydrase, Ca, an enzyme that catalyzes the hydration of metabolic carbon dioxide to bicarbonate and generates the precursor of eggshell carbonate. Based on Figure 4, the highest concentration of magnesium is duck fertilizer, followed by chicken and mixture fertilizer, which is 1.827, 1.676, and 1.638 mg per liter respectively. Magnesium is found in small quantities in eggshells and may impact the eggshell quality. Hence, stronger shells had a greater magnesium concentration than weaker shells, implying a direct relationship between magnesium content and eggshell physical characteristics. Next, the growth and development of 4 houseplants fertilized with each eggshell fertilizer and egg fertilizer were compared by measuring the morphological traits using descriptive analysis. From figure 5, it can be concluded that Syngonium phylum after fertilizing with duct fertilizer had the highest mean of stalk length, which is 9.09, leaf length, which is 6.88, and root length, which is 9.31 compared to chicken fertilizer and eggs fertilizer. Besides, Syngonium phylum after fertilizing with mixture fertilizer had the highest mean of root length, which is 10.9, but had the lower mean of stalk length with value 8.64 and leaf length with value 5.96 compared to duck and chicken fertilizer. According to Kim and Lee 2016, smaller leaf areas and the number of leaves are the most visible impacts of phosphorus deficiency in plants due to slower cell division and extension rates. An increase in phosphorus concentration boosts the growth and development of both shoots and roots, but unbalanced growth of shoots over roots reduces the shoot-to-roots ratio significantly. Besides, an adequate amount of potassium can help produce osmotic potential in the phloem and aid in transposing photosynthesis from leaf to shoots and roots. Thus, the inadequate transportation of photosynthetic product from leaf to roots clarifies that unreasonable potassium supply can inhibit roots growth. Furthermore, lack of magnesium impacts nutrient uptake and level in roots, stem, and leaf. When magnesium is inadequate, magnesium deficiency symptoms first develop in old leaf and then gradually spread to young leaf as the magnesium deficiency exposure increases. Based on figure 6, the height of the first Syngonium phylum before and after fertilizing with chicken fertilizer was 12.8 and 18.7 cm respectively. Next, the height of the second Syngonium phylum before fertilizing was 12.5 cm and after fertilizing was 19.3 cm with duck fertilizer. Besides, the third Syngonium phylum's height before and after fertilizing with mixture fertilizer was 13 and 18.5 cm respectively. The height of the fourth Syngonium phylum before fertilizing was 12 cm and after fertilizing was 18.1 cm with egg fertilizer. According to the results, eggshells serve as a source of calcium for plants. They acidify the soil environment and improve the soil structure. In addition, the fresh and dry weight of the root, stalk, and leaf were considerably reduced by calcium shortage. However, the growth of fourth Syngonium phylum is lower and shows significant wrinkling and reddish spot in the young leaf when fertilized with egg fertilizer. The short plant height and this symptom might be caused by the degradation of nutrients from the chemical fertilizer over time, resulting in stunted development due to an insufficient supply of nutrients. So, organic fertilizer improve the soil contents and enhance the soil physical and chemical qualities through the breakdown of its contents. In conclusion, organic fertilizer were produced from chicken, duck, and mixture eggshell collected from household wastage, restaurant, and fast food industry. Based on the result, duck fertilizer had the highest concentration of phosphorus, magnesium, and calcium. Meanwhile, chicken fertilizer had the highest concentration of potassium. However, ICP-OES could not detect nitrogen with the accuracy and precision required because of the high background impact of atmospheric nitrogen and the intrinsic stability restriction related to previous instrument designs. According to the descriptive analysis, Syngonium phylum after fertilizing with duck fertilizer had a greater mean stalk length, leaf length, as well as height compared to the chicken, mixture, and eggs fertilizer because it has the highest phosphorus, magnesium, and calcium content. Thus, micronutrient availability such as phosphorus, potassium, magnesium, and calcium is required to produce and accumulate secondary substances in various plant metabolic pathways for proper plant growth and development. Hence, the evaluation of micronutrient availability in chickens and ducks eggshell prove that duck eggshells are more valuable because they contain higher concentration of calcium and magnesium, which are necessary for soil deacidification, as well as phosphorus and potassium, which are essential for fertilizer components. For recommendations, I suggest that additional fertilizer components such as nitrogen, sulfur, and sodium could be applied to these fertilizers to increase its effectiveness. In future research, nitrogen elements may be analyzed in each fertilizer since it is important for the growth and development of plants. These are the list of references that I had used in this video.